pi there. So in this video, we'll be working on systems of linear equations. So we will be solving 4 examples illustrating this. Let us start with this first one. So here we are given 2 equations, 2x minus y equal to 24 and x plus y equal to negative 3. In solving linear equations, what we do is solve for x and y given these 2 equations. So how do we do this? There are 2 ways that we usually deal with systems of linear equation. The first one is called elimination, and that is what we will be applying out here. The idea is like this. If we add these 2, so let's say we obtain a sum, say s. This sum s must be equal to the sum of these 2 as well. So let's say this one is 8. So what we will do is we will add this and this in such a way that one of the variables will be eliminated. So to illustrate that one, suppose we set this first equation as I and this second one as double I. Notice that if we add the first equation and the second equation, what we will obtain is the following. So on the left side, adding these 2, so 2x plus x, we will obtain 3x, while minus y plus y would give us 0. So this is the left side. On the other side of the equation, we have 24 minus 3, subtracting or adding that one would give us 21. And then from here, observe that if we divide 3 both sides, so dividing 3, on the left side, the 3's here will cancel, and then on the right side, 21 divided by 3 will be 7. So we will have here x equal to 7. That is the answer for the x component. Only thing that is left here is to solve for y. To solve for y, this one is easy. All we need to do is plug in this x equal to 7 either to this first equation or to this second equation. I would plug it into the second equation. So plugging it into the second equation will give us the following. So note that we will replace x here with 7. So we'll have here 7 plus y equal to negative 3. Then from here, all we need to do to obtain y is to subtract 7 both sides. By subtracting 7 both sides, we will obtain y on the left side, and on the right side, minus 3 minus 7 would give us negative 10. Since we now have x equal to 7 and y equal to negative 10, we can now conclude with the following. So the solution set for this system of linear equations is the following. The point 7, negative 10. So this here represents x and this here represents y. This is the answer for the problem. If you want, you can verify. If you plug in these values out here and here, you must obtain the exact value on the right side, 24 and negative 3. So that is pretty straightforward. Let's move on to the next one. So for this next one, we have 8x minus 2y plus 1 equal to 0 and y equal to 1/2 x minus 3. Earlier, what we did is the elimination method. This time, let us do the substitution method. For the substitution trick, what we do is we isolate one variable in terms of the other and then plug that in to the other equation. In this item, observe that y here is written entirely in terms of x. So by substitution, what we will do here is use this value of y to replace the y on the first equation. So this is how it goes. So first, let us name the 2 equations here. Like what I have said, what we will do is substitute the double I, the second equation, double I, to the first one. So doing that, we will have the following. So we'll have here 8x minus 2. Then we will replace the y out here with this thing out here. So we will have 1/2 x minus 3 to replace the y, then plus 1 here equal to 0. Then from there, let us simplify this one. We start by multiplying 2 out here. So by multiplying 2, we will obtain 8x minus x. Since for this first one, when you multiply this out here, the 2's would cancel. So we'll have your minus x. Then for the next one, 2 here, multiplied here, we will obtain plus 6 since we have here negative 2 times negative 3. Plus 1 equal to 0. Then from here, observe that 8x minus x here would give us 7x. Then 6 plus 1 would give us 7. Move it to the other side and we will obtain negative 7 out here. Dividing 7 both sides would give us x to be equal to -1. So this is the x that we are looking for. From here, similar to the first one, we plug x equal to -1 either to this or to this. Either way, you will get the correct answer, but observe that it is easier to plug in x equal to -1 on the second equation, since the second equation already isolated y on one side. So we do that one. So doing that, we will have the following. So we will have here y equal to 1/2 times -1 minus 3. Take note that this simplifies to. So first, 1/2 minus 1. So first, 1/2 times -1 would give us -1/2 minus 3. And then from here, you could check that this simplifies to -7/2. Once we have this, we can already conclude. So we have the value for x and we have the value for y. This means we can now conclude. The solution for this is given by the point -1/2 7/2. This is the answer for the given problem. So that is the substitution method. Let's now move on to the third item. So for this third item, we have -6x plus 8y plus 2 equal to 0 and 3x minus 4y minus 1 equal to 0. So like earlier, we first name the two equations. From here, again, we have two options. Either we do the elimination method or the substitution method. Here, I think I will prefer to use the elimination method since none of the equations are already isolated. To do that one, observe that in order to eliminate one variable, let's say x out here, we must multiply what to the second equation. What I mean by that is, if we have -6x out here, how would we eliminate it given this? So basically, if we want to eliminate this, clearly what we must multiply is 2. So we will multiply 2 to the second equation in order to eliminate the variable with x. So we will have here I plus 2 times the second equation. Doing that will give us the following. So we'll have here -6x plus 8y plus 2 plus 2 times 3x minus 4y minus 1 equal to 0. Basically, this one is the left side. So this is the left side of the equation and this is the right side of the equation. This came from the first equation. This is 2 times the second equation. So let's solve this one. Multiplying 2 inside this, we will obtain the following. Plus 6x minus 8y minus 2 equal to 0. Notice here that -6x plus 6x would yield 0, 8y minus 8y would yield 0, and 2 minus 2 would yield 0. So what we will have here is 0 equal to 0. Now this is kind of weird. Usually we are left with a single variable, say x or y. But in this case, we don't have any. So how do we interpret this one? Well, what this means is that regardless of the chosen values of x and y that we plug into the equation, we will always yield the following: 0 equal to 0. So this is telling us that for any point, say xy of this solution set, what this is telling us is that the first equation is actually just equal to the second equation. This is indeed true. Observe that if we multiply -2 to this second equation, we'll basically obtain the first equation. So these two are actually just the same equation. Or you could also view it this way. Note that since this one is a linear equation, this is just a line. And these two represents the same line. So if we have here the coordinate system, suppose this is the first equation, the second one is basically overlaps it. Which means that we can actually disregard one of the equations and just focus on one of them because they are just the same. So if you focus on this second equation, note that the second equation can be rewritten as y equal to 3x minus 1 all over 4. If this is the relationship that we have, then our solution would be the following. All points x and y such that it is of the form x, 3x minus 1 all over 4, wherein x can be any real number. This is the solution for this third problem. There you go. So this is quite different from the first one, but I hope you were able to grasp the point of the item. Let's now move on to the last one. So for this last one, we have 2x plus 3y minus 12 equal to 0 and 4x plus 6y minus 6 equal to 0. So like earlier, we named the two equations. So let's apply elimination method here again. Note that what we can do here is multiply 2 to this first one. So by multiplying 2, we will obtain 2 times 2x. This is 4x. And then what we will do is, if we have 4x for the second one, what we will do is subtract the two equations. So to repeat, this is what we will do. So we'll multiply 2 to the first equation and then subtract it to the second one. So by doing that, we will have the following. So we'll have here 2 times 2x plus 3y minus 12 minus 4x plus 6y minus 6 equal to 0. So again, this one came from the left side of the first equation, this from the left side of the second equation, and then adding zeros out here. Let's simplify. So we multiply 2 to this expression out here. We will obtain 4x plus 6y minus 24. And for this next one, distribute the negative sign. We will have here minus 4x minus 6y plus 6 equal to 0. From here, let's simplify. So we will have here 4x minus 4x. That will give us 0. 6y minus 6y. That would also give us 0. So we'll just be left here with negative 24 plus 6, or that simplifies to negative 18. And on the right side, we will be left with 0. Now, this is quite different from the one earlier. Notice that what we obtained is negative 18 equal to 0. We know that this is not true. So what does this mean for us? This means that for any values of x and y, we can never find a relationship between the first equation and the second equation. And this is true. Why is that? Take note that if we multiply 2 out here, what we will obtain in this first equation is 4x plus 6y minus 24 equal to 0, which is kind of similar to this second equation. They only differ here in the last one. If you would recall, in linear equations, that would mean for us that these two lines are actually parallel, which means that if we have this coordinate system, if this is the first equation, say L1, the second equation must be somewhere around here or on the other side. Bottom line is, they are parallel. And when they are parallel, they can never have an intersection, which means that this system of a linear equation will never have a solution. So we can conclude that for this item, our answer is no solution. Or you can write it as an empty curly bracket, or you could also write it as an empty set. This is the answer for this last item. So as you can see in linear equations, there are different scenarios that could occur. One that involves a unique single point, one that involves no solution, or one that involves infinitely many solutions. To end, you may try this exercise out here. This one is kind of tough since we have x, y, and z, so basically 3 variables. But since you are given 3 equations, you can obtain this one. Always recall that the number of variables or the number of unknowns can be solved if you have an equal number or even more equations. So you may try this one out and comment down below your answer to this problem. Your answer here must look of the form value, value, comma, value there. Like here. Your goal is to find these values. Also, take note that please check the description down below as I have a Google form out there that you may answer to help me provide better math content for you in this channel. So that's it. I hope you enjoyed this one, and yeah, have a nice day.